All right. So the test.
No. Maybe you should just drop.
Drop the test.
Yeah.
Okay. Well, let's talk about it. Test was out of 60. Let me just look here, double check something. Okay. The high score.
Well, it wasn't mine.
So this was apparently the most difficult test that you've had so far this year.
Ever. I have never not known so many things on the test as I do now. And the other chemistry test.
Yeah, okay. The average.
Oh gosh.
The average. 31.
Oh.
Which so anyway, let me hand these back and then we will discuss.
This is so bad. Did we curve it or anything?
I have not curved it at this point.
Oh, I think, just to reflect on how hard you tried, you should give us the blessing of the curve.
The blessing of the curve.
Or how does that even work? How do you curve something? You just add as many points.
It depends. There's different ways you can do it.
I think you should curve it from 25.
25 points.
Yep.
See, that would put that at above 100%.
We're not worried about that. It'll be great. Yeah.
Right. I haven't decided yet if I will be doing any curve. There's definitely an extra credit assignment on LMS though.
Is it like one of those really hard ones?
It's actually not. It's
You said that about this test. You said, I remember you said, this is the easiest out of all the tests we've taken. And
I don't remember saying
you
that.
did. You said, this one's pretty easy. I give you all the numbers and stuff, and here we are.
Okay, well let's go over this. Number one, the chemical used to indicate, that is the key word. What is the indicator that we used? That was B, phenolphthalein.
I know. I just realized that
Yeah, that's always rough when you turn in your test and all of a sudden you're like, wait a minute. Anyway, number two, true or false, reduction is a loss of electrons. That's false. Reduction is gaining electrons. Number three, what's a primary battery? That is B.
Yeah, I got that one right.
One that cannot be recharged. 4, true or false, a weak acid almost completely dissociates, which means the hydrogen ion breaks off the atom. That is false. Remember, strong acids completely dissociate. Weak acids only partially do.
Wow.
And what pH is a basic solution? That is C, 10. 3 would be acidic, 7 would be neutral, and B just doesn't make sense. Okay. That is what I think.
Was it 10?
Yeah. All right. Let's do some math. Okay, so calculate the pH of a solution with the OH minus concentration equal to 5.36 times 10 to the minus 10. The trickiest thing here, you're given OH minus, not H plus. Okay. So what we're going to do, first we're going to calculate the POH. Okay.
Okay.
So we do that, put that into our calculator, gives us 9.27. And then we say, oh, well, pH plus POH equals 14. So the pH is 14 minus the POH, which is 4.7. And you got the picture about forgetting the indicator. You know,
I didn't get it.
well, what would happen if you're trying to do a titration and you didn't put any indicator
See,
in?
that's why I felt stupid because it was on the test and it was supposed to be funny, but the fact that I didn't get it was really thanks.
Anyway, so I put it right next to the titration problem too. So you've got 32.7 milliliters of 0.834 molar base. Was needed to titrate 25 milliliters of acid. Acid and base react in a 1-to-1 ratio. What is the molarity of the acid? Now remember, we can go volume of base to moles of base, convert that to how many moles of acid to molarity. Okay. However, there's an easier way. If you use this equation, moles of the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Now, technically, we want to put in moles of acid and base, but since they react in 1-to-1, that just disappears.
Is that a minimum? What? Is that a minimum? Yeah. No. If it was dinner, then it would listen why it would have to be. Oh my gosh, you didn't have to give it back. You didn't have to grade it either.
Yeah, oh, okay.
Oh crap. That's bad.
So, if you plug in the molarities and everything, you get 1.09 mole.
Wait. Oh, what did we learn about that from the equation there?
You didn't. But you could have done it the way that we did in class.
Was the extra credit?
No.
Oh, there was an easier way to you just felt the need to see us struggle.
I felt the need for you to understand why that works.
I don't have to understand why. I just have to understand where the numbers go.
So, next question. pH of a solution is 5.9. Calculate the H plus. You go back to this.
So somehow you've got 1.09.
Yeah, because right here, the molarity of the acid is what we're looking for, so we move this over here.
What the heck? I got one right, even though I had no idea what I was doing.
The molarity of the base is 0.834. The volume of the base is 32.7 milliliters. And the volume of the acid was 25 milliliters. If you set up the unit multipliers, you'll see that this is the exact math that you will do.
I tried. I really did try this.
And that's why you got partial credit. So, anyway, we know the pH is 5.9. We have to solve for this. So that's 10 raised to the negative pH. So we do 10 raised to the negative 5.9, and that gives us 1.26 times 10 to the minus 6. Galvanizing. So remember, we're coating the iron with zinc. There are two things.
Oh, zinc?
Yes, with zinc. So there are two things that this does. First, it provides a physical barrier to corrosion. Second, it provides a sacrificial anode. The zinc will, yes.
Did you see that? Did you see that understanding?
Yeah.
Little light bulb, it went out.
Okay. Okay. We've got this cell, so we need to write the balanced equation and find out what the cell potential is. So remember, the one that is more negative is going to flip around to be oxidized instead of reduced. And that is going to be the magnesium. So our balanced equation is going to look like this.
No.
Okay. So that's our balanced equation. And then the cell potential, remember this is on the front of your shoes.
You don't think I have time for what are you talking about?
Okay. So the reduction is the one that did not flip around, yes.
3, what's that thing in between the 3 and the 2?
That's an M
And, oh,
for magnesium. So we take our potentials that are given to us and we get that.
what is the passing percentage?
I mean, if you want to, it's so.
Is there something you need? Because it wants to be an A. It just needs to pass.
To get a D minus.
Oh, is a D minus passing?
Yeah.
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 But
Is it a good grade? No. Is it passing? Yeah.
Wait, like-
That's 36.
36%?
36 points.
Oh my gosh!
Okay. The oxidation numbers. I'm just going to go through these. If you want more information about how to calculate these, come see me. I don't want to take up too much time. So the arsenic is +5, oxygen -2. And the CO2, carbon is +4, oxygen -2.
Wait, go back.
Okay, arsenic +5, oxygen -2. In the CO2, carbon +4, oxygen -2. Go down to our aluminum there. So aluminum is +3. Phosphorus is +5. Oxygen is -2. And then the hydrogen is 0. Oxidizing agent, reducing agent. Hydrogen is the oxidizing agent because it is reduced. Sodium is the reducing agent because it is oxidized. The pOH of a solution is 13.5, which means it is acidic because we're talking about the pOH. Okay, so the pH would have only been 0.5, which is very acidic.
So it was acidic, not basic.
Yes. Balancing that equation.
Oh gosh.
Once again, to save time, I'm not going to go through every step. If you want to know more, come see me during study hall. But we've got this. We've got another acid-base one. So the pH is 10.6. Calculate OH minus. Once again, we're given the wrong thing.
Why did you want?
So we need to change pH, pOH. And then we throw it in here.
Oh my gosh.
And want to use the other one. Do our rearranging. Throw that in there, and we get 3.98 times 10. Salt bridge in a voltaic cell, it keeps charges balanced. It also completes the circuit. Those two reactions, it's actually the top one that is not redox. If you go through and do the oxidation numbers, none of them change. None of those numbers, none of those oxidation numbers change in that aluminum oxide chromium reaction.
Which one?
The top one. The bottom one, even though it doesn't have any charges, you look at the oxidation numbers, they change. Okay. Here's one that you might beat yourself up over a little bit. What is the value of the ion product constant for water? It's right there. 1 times 10 to the minus 14.
You're kidding.
It's right there. What do we measure all half cell reduction potentials against? That is the standard hydrogen electrode. Hydrogen electrode.
What is it again? 1 times 10 to
Minus 14. Okay. Save time, I'm not going to go through the extra credit points.
That's fine.
There is extra credits on LMS. I advise you take advantage of it. All right. So who's ready to put redox behind us and do something different?
I have a question.
Yes.
So the next test is it like this hard or more hard?
The next test should be
So the next test is going to be very heavily organic chemistry. So
Wait, and we don't have extra one more test in the final?
we just have the fun. There's one more test.
Wait,
Wait,
no
so what's
more.
the final?
What the heck, the hell?
Is the final just like everything we learned over the year?
Yeah, but it's gonna focus mostly on stuff that we've done starting today.
So not,
But
So
they'll-
starting today.
there's gonna be less math,
I
Oh, okay.
really like the idea of that.
but that means more memorization.
I feel like
I
memorization
think
is better.
I can do that a lot better than I can.
Okay,
understand.
well, let's find out. We're starting in chapter 21. Now, chapter 21 is titled Hydrocarbons. Hydrocarbons. So there are two elements that we are going to be dealing with. Can you guess what they are?
Hydrogen and carbon.
Carbone,
Carbon.
like the bones of a car.
Yes. Yes. That's it.
But yes, you are right. Hydrogen and carbon. We're going to be dealing with a whole lot of hydrogen and carbon from here on out. Okay. The reason why we call this organic chemistry has nothing to do with the overpriced vegetables in the grocery store. Okay?
Yeah, why are they so expensive?
Because people will pay for it. Because the organic farmers have done a very good job of convincing people that they're healthier, even though research has not supported that. So, anyway, in case you hadn't noticed, I don't buy organic.
No.
I would have thought.
So, the reason why it's organic chemistry is because for a long time, we could only find these chemicals, these compounds in organisms, living things. Living things. Turns out, living things are really, really good at making organic compounds. Good for you, you're a living thing. So, organic compounds are carbon chemistry. Okay? Carbon chemistry. As it turns out, carbon and hydrogen, they get along really, really well. They love to bond together. Okay? And so we get hydrocarbons. The very simplest organic molecule right there, methane.
Wait, is that hydrocarbon?
That's a hydrocarbon. We've got carbon and hydrogen. That is a hydrocarbon.
That's the simplest?
This is, why did I put a 3 there? That's wrong. Come on, Mr. White. It's a 4. Anyway, methane.
Why is there 4?
Because carbon can have 4 bonds.
Minus or positive. More. Is it from here?
No, that's not a charge. That's 4 hydrogens.
Oh,
No math.
So
Wait, so it's the simplest what?
this is the simplest organic molecule or simplest hydrocarbon, whichever one you want to use. Now, one nice thing about organic chemistry, we get to play with models. So, as we go through, we'll talk about different organic molecules. I will build many of them for you. I have other little kits that if you would like to use them on a test, you can, or if that helps you. You don't have to, but sometimes it helps.
Okay.
Anyway, so this is what methane actually, the structure is. Okay. If you remember, we talked about the different shapes of molecules when we talked about the valence shell electron pair repulsion theory. You want to remember what this shape is called?
I know the shape, I don't remember the name.
Tetrahedral.
Oh,
So when it comes to drawing on the board, however, it's a little bit difficult.
Yeah, you should try to draw that.
Okay. So if we do this,
wow. Oh, that.
we just know that that's that. If you want to be a little bit more accurate, what we do
What the heck is that?
is that,
That was really dumb.
and that wedge signifies that it's coming out of the plane, and those lines say it's going back. But don't worry about that because I almost never do that. But if you ever see that as you're looking at things, that's what it means. Okay. The book does 3D rendering instead.
Yes, we love the book.
Anyway, now we'll bring up this idea of saturated versus unsaturated. Have you ever heard of saturated fat and unsaturated fat? Okay, this is what we're talking about. Fats are long carbon chains. Okay. They are hydrocarbons. If we have a long carbon chain, and we're just going to put 4, that's honestly not very long, but we'll put 4. If there is a hydrogen every possible place,
What the heck?
okay? So every place that we can have a hydrogen, we have one. That is called saturated. Okay. Sometimes, however, you've got a double bond. Now, each carbon can make 4 bonds, but that counts as 2. Okay, so this right here, it's only 1 bond, so we can still put 3 hydrogens there. But this carbon already has 3,
Oh.
so we can only put 1 more. This carbon, 1, 2, 3, we can only put 1 more. This carbon, we can still put 3.
So can you put it in the bottom?
I could. Typically, we'll do it that way though.
So
But if you put it on the bottom, I wouldn't mark it wrong.
1.
Each line represents 1 bond.
Okay.
And carbon needs to have 4. Okay, carbon needs to have 4. So if you look, all of these carbons have 4 lines. As it turns out, this carbon is only attached to 3 different things, but it has 4 lines. That would be an unsaturated because you could add hydrogen by getting rid of that double bond. If you ever see something, if you're looking at food ingredients, and it says it's hydrogenated oil, we've taken an unsaturated fat and added hydrogen. Hydrogenated oils have a better shelf life. We can add hydrogen here. As it turns out, there's other things that can be added here, like sulfur. And if sulfur starts attaching to the fat molecules in your food, it starts to taste like rotten eggs.
Yes.
So we use hydrogenated oils, saturated oils have a better shelf life. Okay. The book goes through refining hydrocarbons, how we can separate them by fractional distillation. Basically, the more carbon something has, the higher its boiling point is. And so we have this column with different temperatures, and they will condense out at different temperatures so we can break them apart by how big they are. You might run into a question like that on the homework, but yeah. Anyway, let's actually just move into section 2, because that's really what the bulk of what we need to know is.
Oh,
Section 2, we introduce the concept of alkanes. Alkanes. Now, it says alkanes are hydrocarbons that have only single bonds between atoms. So no double bonds. We're going to leave double bonds for another day. Right now, we only care about single bonds. Okay? So, we already had our methane. Okay? If, however, we add a second carbon, that's a different molecule. That happens to be ethane. So methane, 1 carbon, ethane, 2 carbons. If we add another carbon to 3, that's going to be propane. 4, butane. 5, pentane. 6, hexane. 7, heptane. 8, octane. 9, nonane. 10, decane. Okay. So, you will need to be able to name hydrocarbons.
just from seeing them or from?
Both. Primarily seeing them. If I give you an equation, most likely, or a name, most likely you're going to have to draw it. So, if you notice, if you look at 751, where it has the first 10 of the alkane series, we have all the names. Okay. Notice they all end with ANE. Okay. If you are dealing with an alkane, the name is going to end ANE. Okay. And then it's a matter of counting how many carbons. So if I had 5 carbons in a chain, all single bonds, what's the name? We know it's going to end with ANE. So what is the prefix for 5? Pent. Okay. So pentane. Now, they also will show you the condensed structural formula here. If you notice, once you get to octane, you don't want to have to write out all of those CH2s. So they put those in parentheses. Now, for me, I find it even faster to use a stick diagram. So let's draw octane on the board, how you're going to see it most often from me.
What are you doing with the compound?
That's octane,
Huh?
because this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8.
Yeah, that makes, oh, you
So
said
if
them
you
like,
have like
like,
that,
It that's so if you look at the ball and stick model, it's very similar to that, except we're going to leave off all the hydrogens. And we're just going to assume that any place that you could have a hydrogen, there's a hydrogen.
Okay.
Don't worry, this is going to make more sense as we go through. Okay, I promise it's going to make more sense.
Oh my gosh.
All right, all right. Okay. Now,
It's like false advertisement.
there were like 5 acid-base questions that were all exactly the same.
Well, yeah.
And all of the equations that you needed were on the front of the test.
That just makes it harder though, if you put so many of them, because if I don't know how to do it.
But how to do them is on the front of the test.
Yeah. I can't argue. I know, I can't. You just point at all of it.
Anyway, so
So what are the points then?
anytime you have the end of a line, that represents a carbon.
And the hydrogen.
The hydrogens,
They're there.
we assume that they're there.
Sure.
Okay. So what about that? What is that molecule?
it's for free.
Okay, there are 3 carbons. So what do we call that?
Okay.
Propane. Very good.
Yes, Wendy.
So what is it called?
Because it is.
Marcus, you know.
we really wanted to.
1, 2, 3, and 4. Those names don't really make that much sense.
Yeah, it should be dose team or trace team.
You mean triane?
Trace team.
Trace tane. Anyway, really all you have to do is memorize those first 4, and the rest of them make sense. 5, like a pentagon, hexagon, okay? It's pronounced butte, not butt. Butane.
Wait, do you know these numbers?
Oh yeah.
Oh, I thought it was really funny.
That was funny. Okay, wait, I'm confused.
What can I help with?
Well, wait, so it goes C2, C3, C4, C2, C3, C4, C5. What the heck happened in that thing?
What do you mean?
Why is it
Let's say at the top.
C1? Oh, wait.
C1 is like.
Oh, wait. Never mind. I understand now.
Okay,
You're slow.
Well,
now let's try another one.
okay. That's fine.
Okay, there's 5 carbons. What do we call that? Pentane. Very good. What about that?
What the heck is that?
I don't know what that is, but I assume that it's just.
Okay,
Friends.
this is a branched chain alkane. Okay. We don't have to put all of our carbons in one nice little line.
Oh, we should.
Who was like, and let's just add a little branch here.
Nature.
Blah, blah.
Okay. So when we have a branch chain, how many total carbons are in this now? So we have 6 carbons. Everyone see that?
Yeah, can you put little dots, please, where they are? Like 1, 2, 3, 4,
5.
and then the one. Okay. So the connected.
So what do we call this is the question.
Hexane. Oh.
It's not hexane.
It's not, what the heck?
First, we need to count the number of carbon atoms in the longest continuous.
The longest continuous chain. Very good. How many carbon atoms are in the
5.
longest continuous chain?
5.
5.
Use the data
So,
for straight chain
That
atoms.
means,
Wait, what?
so basically what you want to do, you want to find the longest chain that you can count. Okay? So 1, 2, 3, 4, 5.
Oh, okay.
And that
That's a parent.
is the parent chain. So since there's 5, that means we're dealing with pentane. But we've got this other little thing that we need to deal with.
What? Oh, the one.
How many carbons are part of this?
Oh,
This side?
One.
Yeah, 1. So what's the prefix for 1 carbon?
no.
Meth. Okay,
Would it be pentane and methane?
so
Pentamethane.
Yeah. Lord.
methylpentane.
Oh, I was so close.
But we're not done.
Oh, no.
You just laugh.
Oh,
What about this?
this. 1, 2, 3, 4,
So that
5.
would be 2.
I don't know.
What?
Is that the same? Is that the same?
This is also
Muscle.
methylpentane, but they're not the same.
What?
So how do we tell people what we're dealing with?
No, it's from them.
We number it.
Oh.
We have to number our carbons. So if we say this is carbon 1, carbon 2, carbon 3, 4, and 5, this becomes 3-methylpentane. It tells us where the methyl is.
So this would be 4-methylpentane.
Except
Oh.
What the heck?
you want to make the number as low as possible.
So 1, 2, 2.
So it's 2. We're going to start numbering from this side.
That's
Oh,
so
okay,
crazy.
okay.
Look at me understanding.
Okay.
Sometimes
Feel like our hearts are beating.
I do.
it's crazy when you understand and you know how.
So we slow down a little bit.
Oh, it's not for.
It's not 4-methyl because we want to make the number as low as possible.
So he's trying to spell it.
So we're starting here instead of here. Because remember, this is an actual object that can move around in 3 dimensions. Those are the same thing. All I did was take this and flip it around like this. Okay, so you cannot get in the habit of always numbering from one side. Okay, you have to look and see where it's going to be.
So neat.
Let's try another one.
Yeah.
What about this one? I added another thing right here.
That's 3.
two,
So it's
is it
cold.
five?
Oh no.
Seven.
1, 2, 3.
Seven carbons.
So there are 7 total carbons, but we care about the parent chain.
Oh, so would it be three, two, no, I don't know.
4, right?
Two.
4.
Well, let's just, where's the parent chain?
Oh, wait, you
How
want-
many carbons do we have in the parent chain?
Five. Right?
Are you sure?
I don't know, now you're making me forgot. I was kind of confusing.
Oh,
Why
that's
why-
longer.
why the other guy?
Because
Look at
this
the
is a
longer.
longer chain. I can get to 6.
Oh. Oh.
I can almost promise you, you will see something like that on the test.
It'd be so crazy.
Okay?
Oh, so we don't count the,
This one is now the side chain.
oh, okay. So it'd be, so
So that would be
that is so fun. So it would be three. Three.
It is 3 something,
Three hydro,
not hydro.
hollow,
No. How many carbons are in this side chain?
carbo.
Just the side chain.
That's one.
The side chain only has 1, right?
Oh.
Meth.
Oh. Methyl.
And how many were in the parent chain? 6, so it's hexane.
What is methyl? Why does that word come to my head? It's where
Sounds like a medication.
so why is it 3?
that word, because of the count below.
Oh,
Oh. Okay, can we try another one where we try to confuse us?
only these 2.
This is the example problem on page 754.
No, I don't. It doesn't give me- Why does this have many?
Okay, we can have more than 1 side chain.
Why?
So where's our parent chain? Just the parent chain.
Oh,
8. Okay? 8. So we know we're dealing with octane. Okay,
oh, I just.
okay. So now let's look at our side chain.
There's 3 meth.
So here we have a methyl,
And then another.
and there's another methyl.
And then.
What's this?
ethyl.
That's an ethyl.
That's
So now I can tell you right now, we're going to number from this side because that's going to give us a lower number than starting from there, right? Because we go 1, 2, 3, 1, 2, 3, 4. So we have a 3 methyl, 4, 5.
Wait, so then you don't
1,
go back.
You pick one numbering system for the whole thing.
Oh,
One numbering system for the whole thing. Okay. And then this is going to be 4. So we know we got a 3 methyl, a 5 ethyl, and a 4 ethyl.
you would combine the
So we have to get them all into this name now.
So
8
So which one are we going to put in first?
meth.
the ethyl.
It's one of those. Turns out it's ethyl. And the reason is
Lower
we go alphabetically.
Oh.
Okay.
Sure, why not?
So we have 4-ethyl.
And 8.
Can you combine the two ones?
And then for this, we are going to combine them. We're going to say 3, comma, 5 dimethyl.
Where's the dye come
2.
from? Oh,
Di means 2. If there were 3, there would be tri. If there were 4, I don't think you'll ever see this in this class, it would be tetra.
So do we need to remember those words?
Yes. So for Wednesday, I will have a sheet that has a whole bunch of information for you.
okay.
Okay?
It's not like they're trying to test you.
No, it's just naming rules. No equations, just naming rules. So I'll print that for you on Wednesday. So 4-ethyl, 3,5-dimethyl octet,
Wait, 3, 5. Oh, it's 3, 5.
because it's on 3 and 5. Yep. Okay. Now,
Oh, don't even.
we can make ring structures.
No.
These are called cycloalkanes. Okay.
1, 2, 3, 4.
So how many? This actually is easier because the ring is always your parent chain.
Oh.
Oh,
The ring is your parent chain, period, end of story. Now you can have multiple rings in the same structure, but I will not give those to you.
That's good.
Okay. So for this class, the ring is the parent structure. So parent chain. So how many are in the parent chain? 6. We have 6 carbons. And we have
1, 2, 3.
3 methyl groups. The hardest part of this is numbering. Okay. You want to pick the overall lowest numbering scheme. So obviously you're going to pick one of these methyl groups to start with number 1, because that's going to be the lowest. Okay. But picking the right one and then going the right direction make a difference. So let's say we pick this as 1. And then go 2, 3, 4, 5, 6. So that gives us 1, 3, 4. If I were to go the other direction, 1, 2, 3, 4, 5. 1, 4, 5. 1, 3, 4 is overall lower than 1, 4, 5, right? Yeah.
1, 2.
That makes sense to you?
Cover
On the top.
one.
But if we go 1, 2, 3, 4, then we get even more. So this is 1, 2, 4 trimethyl cyclohexane.
Oh,
1, 2, 4 trimethyl cyclohexane. These names get very big.
Who write those names?
IUPAC. Just as an example of how these can get very interesting. I don't have this one memorized, so come on. Okay. So here is something that you're all very familiar with, but not by this name. RS 2,4,2-methylpropyl phenyl propanoic acid. That's ibuprofen.
Oh my gosh.
It's chemistry. So, it's going to take a little bit of practice to really figure out these names.
Wait, do they say, so like, would you say that in a different language?
It would be pronounced a little bit different often, but these are fairly international, yeah.
So it's like its own language?
Chemistry is kind of its own language, yeah. Anyway,
Put that on my resume. Can partially speak, partially fluid, but not fluid chemistry. What?
okay. Most of that is practicing with the names.
Oh, okay.
Okay.
Names are just funny.
A large part of organic chemistry is names, at least for high school. Taking organic chemistry in college, which unless you are in certain majors, I doubt you'll have to. It becomes a lot more complicated and reactions and things like that.
So what major do you have to take to learn more organic chemistry? Pharmaceutical or something?
Oh yes, if you wanted to do pharmaceutical stuff, you would absolutely have to take it.
That's not what I'm saying. I don't want to do that.
Also, if you wanted to become a doctor,
Oh, yeah, I'm becoming a doctor. You want to accomplish anything, become a doctor. Yeah, because that's easy.
but yeah, I mean, it's still a whole lot of memorization, but also it's a lot of why does this behave the way it does, not just memorize
Oh, I don't want to know
it. Okay, so there's that. If you have questions, obviously come ask. Also, there are a bunch of naming rules in the book, but I will also have a sheet for you next time.
Can we use